Hello everyone, this is Ayush R from IIT MADRAS, your mentor. Today our topic is orbital velocity of Earth. What do you mean by orbital velocity of Earth? What actually orbital velocity refers to? Consider a satellite revolving around the Earth. Consider a satellite revolving around the Earth. Consider a satellite of mass m. Consider a satellite of mass m revolving around the Earth. So the mass of Earth is considered as capital M. The mass of Earth is considered as capital M. A satellite is revolving around Earth and the mass of Earth is capital M. So we have to calculate the velocity through which this satellite is in orbit of Earth. This satellite is executing the orbit, okay, remaining in the orbit of Earth and not leaving its orbit. So orbital velocity is represented by VO. Orbital velocity is represented by VO, and VO is taken from a formula. Since in order to move in a circular path, a body needs centripetal force, which is represented by MC, which is directed towards the center. Centripetal force is directed towards the center, okay, and some of the force is required to balance this centripetal force. Some force is required to balance this gravitational force. Say here, which force in terms of gravity? Here, force of gravitation acts. Force of gravitation acts between the Earth and satellite. So Fc, in order to move a satellite around the Earth in a circular path, circular orbit, the Fc must be equal to Fg. Centripetal force must be equal to the gravitational force between Earth and the satellite. So this will be the first equation. In a circular orbit, Fc must be equal to Fg. Every time we will equate these two equations. So centripetal force is nothing but it is Fc equals to mv square by r. Let the velocity of orbit, let the velocity of satellite through which it is orbiting around the Earth is VO. It is represented by VO. So Fc must be equal to mvo square by r. That's the second equation. And the force of gravitation, is equal to G, mass of satellite multiplied by mass of Earth upon radius of Earth whole square. Radius whole square. So the distance between Earth and the satellite, let us consider here r. Okay, r. Let r be the radius of Earth. So these two equations, equation number 3 and 4, equation number 3 and equation number 2 must be equal according to the first equation. These two equations must be equated. On comparing these two equations, we will get the orbital velocity, the expression for orbital velocity. So G m by r square must be equal to m v naught square by r. M v naught square by r. Since equation first equals to equation number second, so m to m will be cancelled out. This Gm by r square must be equal to v naught square by r. So 1r to 1r will also be cancelled out. 1r to 1r will also be cancelled out. Gm by r is equal to v naught square. Gm by r is equal to v naught square. So that is the final expression. On taking square root on both sides, we will get, on taking square roots on both sides, we will get v naught square. Okay, taking square root here also equals to Gm by r whole under root. Gm by r whole under root. Where m is the mass of Earth, capital M is the mass of Earth, r is the distance between satellite and Earth center and the the orbital velocity through which the satellite is orbiting around the Earth in circular orbit. So these equations are equated and the final expression is root over 2 square will be cancelled out. So V naught is equal to roots over of Gn by R. V naught is equal to roots over of Gm by R, where G is the capital G is the universal gravitational constant whose value is 6.67 into 10 to the power minus 11. 6.67 into 10 to the power minus 11. V naught is equal to roots over of Gr. V naught is equal to roots over of Gr.